you experiment boomerangs of different size. If you in the front row, I'm stuck.
Right. Well, good. So, some of you were at this morning's lecture, I hope. And you've seen that I started throwing some boomerangs. And, well, you remember that I said that these were boomerangs, well, essentially two boomerangs stuck side by side. And these turned out to be nice and easy to throw indoors. Because they're made of balsa wood, it means when inevitably it does hit somebody on the head, it's fairly soft. And it did that help? It didn't hurt, not so hard. So I can't really hurt very much. Okay. Now, I'm going to start off with a little this one here. Okay. There's instructions on how to make these on my website. So you want to make a balsa wood. And I can throw this around and it comes back to me. It comes back to me like that. And what you notice is that it's spinning and moving forward. If I don't spin it at the right speed, so if I don't give it much spin at all, it doesn't work. If I spin it too much and don't give it much forward speed, doesn't work. You're in a good spot there, aren't you? So what we've established is we can go back to the 3D Slido. There we go. What we've established is, last time pages on the pointer, what we've established is that this thing here is important that I get it right. So let's see if I do get it right. Turns out this value has to be something like root 2-ish. You can go to the website to figure it out. So let's suppose I keep down about root 2. And this thing, or area of the fixed density of my balsa wood is a fixed density, and lift coefficient, that's the same as the design. The radius then of flight is proportional to the radius applied to the boomerang. Let's try that. I'm going to throw this gently, and let's see how far back it goes. So just tell us roughly where that gets back to. Okay, so how far back did it go? Put your hand up and go over your head. Sort of right there, okay? Right, yeah. Now I'll chuck it much harder, spinning faster and going faster.
Oh,
right, so where does that go?
do same.
Same length. Right, okay. So in other words, even though I throw it faster, then my 60-year-old is right. Even though I throw it faster, I did omega faster and big faster, earlier space, rate space. So then I think to myself, I think, right, boomerang is twice as big. It's exactly twice as big, twice as long, twice as wide, twice as thick, still made of balsa wood. Right, how far back does this go? Well, I'm sort of going to guess it's going to go twice the distance. Let's have a look.
Oh.
Let's see that right, where's that go? Down there? Check, you can be a beauty taker.
Yeah, so that's back to the 6th row, roughly. And the previous one got back to the 2nd row, and then we kind of
Gap in the middle.
goes back 3rd row back. So it's almost exactly twice.
So we go. Serious legend then.
Yeah.
So we just double the size. Right, so this one is twice as big.
What?
Twice, the thickness is twice.
Oh. It's scared.
You might throw this one that way.
Oh,
I didn't do this year.
right, yeah, okay. Alright, I'll do my... Right, so let's suppose that I've got to go back a long way to make this work. So I'm actually going to go back pretty much to where the first one actually was.
Oh.
Right, yeah. Now, according to the theory, it should actually go much further back. I'm sort of thinking that this is going to disattain the theory, and actually it's only just going to get to the whiteboard. Does anybody right. I'll do it again. This is pretty much where the previous one came to, yeah? But this one is not going twice as far. There we go. Did you come back? Sorry, I'm bad. Right, Whee!
Whoa!
Right, I'll do that again. Right, so that's quite interesting because no permanent injuries there. Okay. Good. So that's really odd. This one is twice as big as that. That sort of suggests that there's something funny. And the answer is that we've gone into a different regime. What tends to happen is with wings and so on, you can do a wind tunnel test, and you can discover that actually this Reynolds number similarity is very important. The idea that if you move a wing through the air faster, that the lift coefficient stays the same is not actually correct. So this thing called lift coefficient, CL, seems to be pretty close to the same for smallest wind rate, but once you get the big one, it changes. So dimensional analysis is really good, but there are points when it breaks down the inverted commas, what it means is you've made not such a great assumption that perhaps you should have. Is that the kind of thing you want me to say?
Brilliant. Thanks very much.
Good. Great.